Hi, this is Clayton with Mind of Its Own Design. There are a lot of misconceptions about what glass is. Sometimes people might say glass is like a liquid and then you can see that when you go to an old cathedral and that the glass is thicker at the bottom of the window panes, and therefore people say, oh, it's actually really just a glass, but just a liquid, but a slow moving one. I believe that is a misconception. But to explain what a glass really is, you actually have to ask a different question. And that question is, what is a crystal? And the reason I say that is because a crystal and a glass, they're like cousins. You can have the same makeup, in this case, chemical composition, SiO2, in the dual case of glass and silica quartz, sometimes known as sand. You might see this material, or you might see it as large crystals, many faceted with points and distinct sides to them. That's a quartz crystal. I think people commonly think of crystals as what you see, the amethyst or other minerals, where they basically have this geometry. But actually, a crystal is what's a representation of the structure of the atoms that make up any material. So if you have like a three-dimensional box that contains some atoms of your material in the ratio of, in this case, 1 silicon to 2 oxygens, SiO2. Now, in your imaginary box, you have certain connections between silicon and oxygen, and it's a three-dimensional thing. You could think of it as a bunch of spheres, like this model here, which is actually for the crystal structure of diamond, but it's actually a similar crystal structure to quartz, one of the forms of quartz. Except in a diamond, all of the atoms are one element, which is carbon, but in a quartz crystal, all of the elements are composed of silicon and oxygen. And then there's sometimes other elements in nature, and when we make different changes. Now, what would happen if you melted a piece of quartz? I think that'd be a more interesting question than, is glass really a liquid? Because what glass is actually just considered without to have long-range shape, or without a certain shape to its atoms, otherwise known as amorphous. I'll get back to that in a second. But when you have a periodic arrangement of atoms or groups of atoms in a crystal structure, this leads to the properties on the scale of the atoms transitioning sometimes into the properties on the larger scale. So quartz, these are what are called single crystals. But actually most things are composed of crystals, but actually, like metals, for instance, are much too small to see each individual crystal. So when we look at a piece of metal, we just see a flat piece of metal. Sometimes traffic posts outside, because of the way that they're cooled, you can actually see the grains, or otherwise known as crystallites, which are multiple crystals within one larger unit. Okay, so this is a lot of talk about crystals, but the question was, what is a glass? And it's important to know that a glass has an order to it, but it has a short range order. When you look at a glass, chemistry and physics tell you what ratio you're likely to find and how many bonds between silicon and oxygen you're likely to have statistically. But in practice, around each atom, there's nearest neighbors. There's an environment where each atom are touching several other atoms, like spheres in like ping pong balls in a milk crate. Now, if you look at this right here, this structure is very similar. However, there are these large gaps in the structure. And in those gaps is what gives you the property in glass of transparency. Literally, light waves can go through and statistically not bump into too many atoms as they would if you go in through quartz. Because anyone who's seen a piece of quartz knows that it would make a less than perfect window. That's because the atoms are arranged in such a way that light actually has a harder time penetrating through the structure. The glass has this combination of short range order and no long range order. That's referred to as amorphous, which the root means without shape. So that's what glass is. Glass is amorphous. It's not a liquid. It's just that liquids are also amorphous. There you go. That's how it connects. So when you melt a piece of glass or a piece of quartz, and those bonds start to break because the atoms are moving and it's becoming less viscosity, more fluidity, and eventually the bonds are continually breaking and undoing their bonds. And that's just like in liquid water. That is how a liquid is that it's a continual temporary bond situation, and it's because of the energy that you put in to get it to be a liquid. That's why when you cool that thing that you put in, whether it was glass or whether it was quartz, into this furnace, let's say, and melted it, you're gonna get out glass. And the reason is that in order to get these perfect arrangements of the atoms in this crystal lattice, this three-dimensional lattice, you need to cool it so slowly. I mean, remember, this is like a stone or a ceramic, if you will, where you have these materials that their bonds are strong. They don't want to rearrange into this thing. They do, but it will take so long. And so the only place you can get such long cooling times, where something stays hot for so long and it turns into this other thing, fundamentally, you could probably reproduce it in a laboratory, but fundamentally that happens in the earth. That's why when we make glass, it just no longer looks like the sand that it was made from. But if you break up quartz, it looks like sand. It doesn't look like broken glass. That's all about the atomic structure and how the atomic structure or the crystal structure represents itself in the real world as an object or a material. So, in conclusion, I would say the reason that those glass things in the church look like they're wider at the bottom is one of my teachers one time told me is that if you were making a window, you would just put the heavier side of the non-uniform thickness of glass, which was technologically was limiting at that time. you would just put the heavier side down for stability reasons, and I believe that's true. Now, that's not to say if you don't heat up, if there was a fire in a building like that, then glass would approach its liquid state. So yeah, if there was a fire, you might actually see some pooling of glass. And yeah, so now you know, I think you know what the difference is between amorphous glass and crystalline quartz. But please check out mindofitsowndesign.com and like and subscribe. Thank you.